Okay, Algebra 2, Section 3.5. This is the last section in the chapter, and this section is on solving nonlinear systems. So most of the examples we're going to do in this section are one equation will be a parabola, one equation will be a straight line, and these are the three possible scenarios you're going to have. Either those two functions will never meet. They'll meet at one spot. In other words, this line is tangent to that parabola, or the line goes through the parabola at two distinct points. So just like solving any systems, there's going to be three methods that we're going to discuss. The first one is by substitution. So let's look at this example. Our first equation is x squared plus x minus y equals -1. This obviously is quadratic, it's a parabola. And this is a straight line, x plus y equals 4. So I'm going to go ahead and solve equation number 2 for y. And when we do that, we're going to get y equals 4 minus x. So then I'm going to take this and substitute it for that y in equation 1. So when I do that, it's going to look like that, which gives me x squared plus 2x minus 4 equals -1. Put that in standard form. I chose to factor this because this is an easy one to factor. And as you can see, that would give us either x equals 1 or x equals -3. So now we know what x is, or 2x's. We need to find the y values. So I'm just going to go back to this equation to find my y's. And I'm just going to plug in my 2x's there. And when I do that, you'll find that y is either 3 or y is 7. So in this one, when x is 1, y is 3. When x is -3, y is 7. These are the 2 points that these two functions will intersect. So the next method of solving a nonlinear system is by elimination. So equation 1 is 2x squared minus 5x minus y equals -2. Equation 2 is x squared plus 2x plus y equals 0. So you'll notice this time that we have two parabolas. So I'm going to go ahead and put both of these. Actually, I'm just going to add those two together, because look what happens when you add these two together. The y's disappear. And you end up with 3x squared minus 3x equals -2. And put that in standard form. Always put it in standard form when you're solving for x. And I'm going to use the quadratic formula for this one. Okay, notice that this is going to be -24. 9 minus 24 is negative, which means I'm going to have imaginary numbers. And because the discriminant is less than 0, this system has no real solutions. You can check this by putting both of those systems into your graphing calculator, and you can see it looks somewhat like that. And you can see that those graphs do not intersect. So the third system or method of solving nonlinear systems is by graphing. And I'm going to tell you, for these kind of systems, this is by far the easiest method and the most accurate. On the test, you may have to do one by substitution, one by elimination, and then the rest of them I would suggest you use your graphing calculator and do it by graphing. And we'll do a bunch of those examples when we are together in class. That's it for chapter 3.